looking at some examples from 5.1. First, I'm going to talk a little bit more about the standard normal probability distribution. So I left some things up here from before the break. I left this up here, that the standard normal probability distribution, that there's a table, and we're going to look at that table in a minute and see how to use it. And it shows probabilities to the left of the z-scores. It's really showing the area under the curve. So I'm going to change that. Plus I misspelled probabilities. That shows area under the curve to the left of the z-scores. Okay, now what we're going to do is we're going to come back and we're going to look at this bell-shaped distribution, and this is just the normal, and then we're going to change it to the standard normal probability distribution. Now, I looked up a particular example. I've used this example many times before, but I've never actually looked it up. So I looked this up during the break, and I found out that adult women's heights, I put in the USA, so I couldn't really tell if it was just USA or the world, but anyway, I had Googled the mean. I wanted the mean and the standard deviation for adult women's heights in the USA, and this is what came up. On most places, it seemed to agree that the average height is 5'5" or 65 inches, which was disappointing to me because that's how tall I am, and I've always thought I was taller than average. Apparently not. So what that means is that if I'm looking at data values, I'm putting data values here, so I'm going to call this X. X being the data values, like the actual heights in this case. So we're going to do this in inches because it's a little easier. Then 65 inches would go right here in the middle because the mean is always in the middle. And then I found that the standard deviation for adult women's heights is 3.5 inches. So when I go to the right 3 times, I'm going to add 3.5 over and over again. So one standard deviation to the right would be 68.5. And if I add 3.5 to that, that's going to give me 72 inches here, which is 6 feet. And then this would be 75.5 inches here, which ran into my X. Sorry about that. Let's put an X here. X would be what we're doing if we're just doing a regular, demonstrating a regular normal distribution, probability distribution. And then when I go to the left, I'm going to subtract 3.5. I'm not as good at subtracting, so I'm going to do this in my calculator. So I'm doing 65 minus 3.5. So that would be 61.5 inches here. Minus 3.5 again would be 58 inches right here. And then minus 3.5 again would be 54.5 inches. Now, if it would make more sense to you to have these written in feet and inches, remember 65 inches, that's 5'5". So that's the average of women's height. And then 68.5, 5'5" inches. And then we're adding 3.5 to that. So 3.5 inches, so that's going to be 5 foot, and then that's going to be 8.5 inches. And then 72 inches is 6 feet. So this would be 6 foot, 3.5 inches over here. And then going backwards, I subtract 3.5 inches. This is going to be 5 foot, subtract 3, 5 foot 1.5. And if I subtract 3.5 inches from that, I'm going to be at 4 foot Well, 4 feet is, that's going to be 4'10". And if I subtract 3, that's going to be 4 foot 6.5 inches. So just to give you an idea of what this would mean using the empirical rule, which we've talked about before, this would mean that we would expect 68% of all adult women to be between 5'1" and 5'8" about. We would expect 95% of adult women to be between 4'10" and 6 tall. And notice if you looked at the area under the curve, that would be quite a bit of the area. And then we would expect almost everybody, 99.7%, to be between 4'6", which is about 4.5 feet, and 6'3". Remember, this is women. So that's based on actual statistics. Now, if I wanted to find the probability, or if I that someone was, say, okay, let's just do mine for an example, because that one's easy. Since I am 5'5", if I said the probability that someone is less than 5'5", well, that's going to be the area under the curve to the left of this. Less than will be to the left, and greater than would be to the right. So since I'm right in the middle at the mean, the probability is 1/2 or 0.5 on each side. So the probability that someone is less than or shorter than 5'5" is 0.5, and the probability that someone is taller than 5'5" is also 0.5 or 1/2. Now, when we change that to the standard normal probability distribution, then that means we convert these data scores all to z-scores. The curve looks exactly the same. I'm going to try to draw it exactly the same. So the curve is still going to look, it's still going to be the same curve, except if I do the z-score for 65 inches here, let's just do that one right there. If I did the z-score for a data value of 65 inches, remember our formula for z-score is you take the data value minus the mean and divide by the standard deviation. If I do the z-score for this using this information, then my z-score would be, the data value would be 65 minus the mean, which is also 65, divided by 3.5. And notice that's going to give me 0, because 65 minus 65 is 0. So that means the z-score for 65 inches is 0. And in reality, we didn't stress this that much when we were doing z-scores before, but actually z-scores are the number of standard deviations from the mean. So when I go to 68.5, if I put that in right here to find the z-score, that's going to come out to be 1. So the z-score for this, so when I'm doing z-scores, this z-score is 0 for the mean. If you're 1 standard deviation above, the z-score is going to be +1. If you're 1 standard deviation below, the z-score will be -1. And so your curve and labels end up looking like this. And then no matter what data set you're looking at, the mean will always have a z-score of 0. And then all of the data values will, almost all the data values will be within 3 standard deviations, or another way to say that would have a z-score between -3 and +3. So the z-score correlates exactly to how many standard deviations the data value is from the mean. And if the data value, the actual number, is lower than the mean, it will have a negative z-score. If it's higher than the mean, it will have a positive z-score. So here's the advantage in this. So this is what the standard normal probability distribution looks like. It has a mean of 0, and the standard deviation is 1, because notice we're counting by ones. So the mean is 0, and the standard deviation is 1. Now, the advantage in changing everything to the standard normal distribution And guys, the main difference here, this represents the same data set as this. This can be used to represent all data sets, but it represents their z-scores. That's what standardizes it, is changing to z-scores. Otherwise, if you're just looking at the x's, like this one, those could be anything. So this is women's heights, but say you were doing babies' weights, okay? Then the middle number is going to be, I don't know what average baby weight is, maybe, I don't know, 7 pounds or something like that. So that number in the middle would be 7. If you were talking about the average size of a particular tree grows, that might be 30 feet. So these numbers will be different for all data sets. For every single data set, these numbers will all be different. But if you change to z-scores, it always looks like this. So we're always going to look at the standard normal, and we have a table that gives us probabilities for the standard normal distribution. So, and I'm going to talk about that table again. I'm going to pull it up. So the standard normal distribution table, and you will have to have one of these printed out, guys, for your next test. They have one that you can pull up in my stat lab, and that's okay, but I find it much easier to do if you have a printout of it. Standard normal distribution table, and I want you to write this down and highlight it. What it gives the area to the left of a z-score. Gives the area to the left of a z-score, which will correlate to the probability that the z-score is less than a certain number. That's what it will give you, because to the left is a less than. But remember also, the total area under the curve, this is something to remember, still has to be 1. We did not change the shape of it. We didn't change any of the probabilities. All we did was we changed the numbers across the bottom to standardize it so that we could use these same numbers for every single data set. Let's look at the standard normal distribution tab. So I think I have it here to pull up for you. There it is, z-table. And this is one page, and it's 2 pages. So on this page, look on the left column, and you see negative z's starting at negative 3.4. And if you scroll down, it goes to negative 0.0. Now notice it only takes the z-score out to the 10th place. So most of the time, we will be doing z-scores, looking at z-scores that go out to the 100th place. So what they do here is they give you the number that goes in the 100th place across the top. And this table gives you the area. Look at the picture at the top. I'm going to see if I can get my pen to work today. I'm having some issues with my stylus pen, but I'm going to give it a try just in case it works. Not great. But I'm going to fix this up. So I want you to look at this. It gives you, they tell you in the legend at the top what the table is doing. You notice they've shaded area to the left of a z-score at the bottom. And I'm sorry, I'm going to turn off the video. I know that's got to be looking crazy. I'm trying. I've been having trouble. You guys understand technical difficulties, I'm sure. Okay. I'm going to see if I can get it to work with the mouse instead of my stylus. Okay. So here in this picture, that's the legend for this, and it gives you the area to the left of a z-score. So, for example, if you were looking for, if you were wanting to find the area to the left of z equal negative 2.46, suppose I wanted that. And what I would do is I would first look for, I would look in the left-hand column for the negative 2.4 part. And that would be right here. This table gives me all the areas I need for the standard normal distribution. Notice this says standard normal distribution. That means it's based on z-scores. So negative 2.4, this would be the row that I drew a red arrow to. And then let's do a different color. So to get that 6 there, that means I'm going to use this column that says 0.06. So the numbers across the top give you the number in the hundredths place of the z-score. And then the column over on the left gives you the first part of the score. And this particular page is negative z-scores. So I stay in that column. I cross-reference the negative 2.4 with the 0.06. That's where I get the hundredths place. I cross-reference that row and that column. And that would be this number right here. So that tells me the area to the left of that z-score is 0.0069. So hopefully you can see how we use that, what the table gives you. So first of all, you have to know a z-score. It won't work with the data value. So first you have to convert data values to z-scores, and then the area to the left of a particular z-score is also the probability. So this is also, let me see if I can do this. Probability that the z-score is less than negative 2.46. And another way we could write that, remember, would be the probability that z is less than negative 2.46. So the table gives us probabilities. This is why we did some stuff on probability. It's because we're going to be talking about probabilities. We're going to be using this table throughout the semester. Okay, so I want to show you page 2 of the table. And then we're going to do a few examples. So this is page 2. Now the only difference page 1 and page 2 is page 2 gives you your positive z-scores. So notice the little example they give us up here. Z is to the right of the mean, and there's more area to the left. But it still gives you the area to the left. And one thing you might, a couple of things I'll point out, is if you're looking at Z equals 0.0, this first one, Z equal, notice this one starts at 0.0 and it goes up to 3.4. So it goes past a Z score of 3, but only up to 3.4. And a Z score of 0.00, notice that that area to the left of a Z score of 0, which remember is the mean, is 0.5. But this table still gives you area to the left. So we're going to look at a few examples and see how we would use this to answer a few questions. So let's go to example 1. So the question on this one, I'm going to write the question. The question on this one is to find the area to the shaded area. It just says find the shaded area. Notice in the picture it gives you the Z-score. The Z-score is 0.95. So we want, and notice this is to the left of that. Well, that's what the table gives us, is area to the left. So basically all I have to do is use the table to find the area to the left. That's what the table gives me. So I'm going to go back to my table. And I'm going to look for a Z-score of 0.95. Since that's positive, I'm going to look for positive 0.95. So I'm looking at page 2 where the positive numbers are. And just to remind you, the Z-score was positive 0.95. That was the one we were looking at. If you can find, so I've given you the Z-score, and it's asking for the area to the left. So 0.9, remember I first looked on the column for 0.9, and that is right here. So I want that bottom row there. Those numbers are kind of hard to see. That's why you want to print out. And the number in my hundredths place is a 5. So I need to look at this column here, 0.05. So I'm looking at this column and this row. So that's the number I need right there, which is kind of hard to see. At least it is for me. But it looks like 0.8289. I'm going to draw that. 8289. So that's the area to the left of a Z-score of 0.95. Notice that's more than half. It should be because we are past the mean. Remember the Z-score of 0 would be right here in the middle. That would be 0 right there. That's a Z-score where it's 0. 0.95 would be somewhere like, well, that place where they have that one is about at 1. So it'd be really close to this. And the reason why I know that that's about at 1 is because a Z-score of 1 is at the inflection point where that curve changes from concave down. Let me just kind of show it to you. Concave down to concave up. So that little z they have is about at 1. So 0.95 would be pretty close, really close to that, actually, closer than what I showed. And so that area would almost be the same as a z-score of 1, which you notice a z-score of 1, it's 0.8413. Maybe this was 8289. Yeah. Okay, let's do another example. What if it asks you to find the area to the right? So on this one is asking me find the area to the right. Equal 1.01. That's what this one's asking us to find. Again, that's a positive z, but notice it wants the area to the right. Well, the table's not going to give me the area to the right. The table's going to give me this area right here. So I can get this from the table. I can spell. Not well. There. I'm going to get the area to the left from the table. So I go back to my z table, and I'm going to look 1.01. It's going to be on the positive one, which is the second page, and I'm looking for 1.0. So first I go to 1.0, and then the number in the hundredths place is 1, so I'm looking in the 0.01 column, and I can see that that's 0.8438. That's the area to the left. Now I'm going to go back to that picture that I was looking at. So remember 0.8438. That means the area to the left is 0.8438. That's what I got from the table. And why it keeps giving me two B's, I do not know. Okay. I apologize for saying table instead of table. But the area that's shaded that they want me to find is to the right. But the total area has to be 1. So the way I'm going to find the area to the right, that z-score, is I'm going to subtract off, I'm going to take the 1, that's the total, and I'm going to subtract off that 0.8438. I'll do that in my calculator. 8438, and I get 0.1562. And that would be the area to the right that they're asking for. Now, I know that it's 12:30, and I understand if you guys have to leave. I have a couple more examples I want to do and put on the recording, and it took me a while to get this set up. So I'm going to put a couple more examples on this recording. I'm going to go ahead and do them. If you guys want to stay and listen, that's terrific. But if you don't, that's okay too. Does anybody have a question so far? Okay. I'm going to go to a different example then. This particular question is asking us to find the area between. Sorry. between z equal negative 1.2 and z equals 0.7. So we're looking at doing a between problem. Remember from the table, what I can get is the areas to the left. So I can get the area to the left, and that's going to be the total area to the left of negative 1.2. I can get that from the table. And I can get the area to the left of 0.7. That's all the table will give me are those two areas. Now, I'm not going to switch back to the table this time. I'm just going to look at my table printout. If you have a printout or if you have it pulled up, you can look at yours. But so I'm looking at to get the area to the left of negative 1.2. That's negative 1.20. And that area is 0.1151. That's that area. And then the area to the left of positive, let me make sure I did negative 1.2, right? Yeah. Keep in mind that that is 1.2. When they don't have a number in the hundredths place, it's 0. So this one also is 0.70. So the area to the left of 0.70 is 0.7580. And I don't know why that kind of, okay, let me scroll back. Okay, there it is. To find the area in between, guys, basically what I want to do is I want to take all of this area to the left of this one. So I want to take that whole purple area, but I want to subtract off this part. If I subtract off that part, what I will have left is the area in between. And so I'm going to have to do a calculation on this. So to find the area in between, I'm going to do the whole area from the z-score of 0.7, and I'm going to subtract off that area I don't want. I'm going to use my calculator. 0.7580 minus 0.1151. So I'm taking the larger area and subtracting off the part of it I don't want, and I get 0.6429. And that will be the answer. Those of you who are left, do any of you have any questions about that?
No.
Okay, so there's one last kind. So we did one where the area was to the left, one where the area was to the right, one where the area was in between. And then there's one more kind of problem. Let me see if this is it. Yeah, and there's not a picture of this one, but I can't remember which problem this is out of the book. But, and those of you who are watching the recording, you may not be able to see this, but it says, find the area to the left of a particular z-score, to the left of negative 0.66, and to the right of, and this is what they want you to do. I'm going to attempt to draw a picture of this here. And when you have to show work in my math lab, this is going to be a picture you want to practice drawing in my stat lab. And so right here would be 0. So first they want the area to the left of negative 0.66. So I'm just going to make a mark there and just label it negative 0.66. And then it says and to the right of positive 0.66. So over here would be, it'd be the same distance, positive 0.66. So what they're wanting me to find is, I'm going to try to draw the shaded. Sorry, those lines should be straight, okay? So what they want me to find is this area. And this area. And then what we're going to do, guys, is we're going to add those two areas together. Now to get that area there, that's just the area to the left of negative 0.66. So that area to the left of that one will equal, and that on that one, on that left one, all I have to do is look it up because that's area to the left of negative 0.66. So I'm looking that up on my table, 0.2546. But for this one over here on the right, when I look up positive 0.66, it's going to give me the area to the left. But since this is symmetric, that area to the right of the positive one should be the same as the area to the left. But I'm going to pretend I don't know that. And I'm going to do this. This will be, if you guys need to leave, remember this is going to be on the recording. So the area to the right equals 1 minus the area to the left of 0.66, 0.7454. Now, the reason why these two areas came out the same was because the areas are symmetric. So the area to the left and to the right of these opposites are the same. But to get the total area, which is what they really want, I'm going to put that down here. Sometimes they'll call these two things tails. The total area, I'm going to add those together. 0.2546 plus 0.2546. And then I'm going to add those together. Gives me 0.5092. I'll make that big so people can see it. And the answer they're wanting is this right here. So Diamond and Stephanie, I see you guys are with me still. Do you have a question about that? Does that make sense how I did that?
Yes.
Okay, great. And this is basically all there is, except sometimes instead of calling it area, they're going to call it probability. So what I found right here, that area right there, that was the probability that a z-score is less than 0.66, negative 0.66. That was a less than. And this one that I did over here was probability. This was z less than 0.66. And over here, this other yellow area I found was probability that z is greater than positive. That was negative on that side. Negative, positive 0.66. And so what we just did was we found the probability. Those areas are the same as the probability. So sometimes they ask the questions in terms of area. Sometimes they ask it in terms of probability. And that should cover just about everything. And if you have any other questions about any of the homework, we'll certainly go over that on Wednesday.
And the area to the right, when you find you always subtract it from 1?
Yeah, remember the table's only going to give you areas to the left. So what I had to do was, on this one, when they're opposites like that, you know, notice the area to the left of a negative, to the right of the positive that are the same number are the same, because that's because of the symmetry, but they won't always give you the same. They won't always give you opposites. But yeah,
Right.
so what happened here really is that this area, this total area to the left of this was this 0.7454. So to get the area to the right, I had to subtract that from 1. That's how you'll always get area to the right, is by subtracting the number in the table from 1.
Okay.
Okay? And that's
Okay.
all. And if you've got that, pretty much 5.1 through 5.3 ends up being pretty easy. So this is just the basics of most of the chapters, what we did today.
Okay.